So glad you have. Mesam, I also like you. You also did well. We haven't had a, you know, class in a while. Today I'll be starting electrochemistry. I mentioned that a few times, and I'm just getting my diagrams next to me on my iPad, if you allow. Yes, I just heard Bangladesh CI got cancelled. I know, I know. Our job is to keep continuing you know, till we know anything else. If ours get cancelled, they get cancelled. We can't judge it, right? So, you see, I'm going to share my screen also. So, I'm just setting my screen also with you guys now. Thank you for being patient. For those of you, I don't know if anybody's joined in from anywhere, but sure. All right. I don't know. I don't think anymore about this. I stopped thinking about this part. Will they get cancelled or not? Anyways, so I gotta put my headphones on so I can hear myself loud and clear. Yeah. I don't know. I've been locked home mostly anyway, so lockdown or no lockdown hasn't affected. I mean, I'm not getting out either way. Okay. So let's begin. Okay. Now, before we start this chapter, so this is a chapter for electrolysis, right? So we are doing electricity, really. Okay. So let's begin. Okay. You're welcome, Amara. Walaikum salam, Marisha. I hope you guys didn't miss me too much. I'm sure I was. You better have missed me, but I hope not too much. I missed you guys too. In fact, I plan to take a lot of classes of past papers also next month, say, for both IGCSE and O levels together. Separately, both, but okay. So now I'm going to share my screen also now. And in fact, I'm going to do this is that I'm going to show the other form, right? So let's do that. And in fact, I can just disconnect my that, and you guys can have my camera in front of you. You have that right now? Yeah. All right. Okay. So now what I want to discuss with you guys is, okay, electrolysis. You guys sound okay. Now, so to understand the role of electricity in chemistry, let's understand first why things conduct electricity. We need to remember why things conduct electricity. What is electricity, first of all? We call anything, any passing of charge as electricity. Now, in chemistry, also understand that we have different charged particles. The most common charged particles that conduct are electrons, but they're not the only ones. We also have cations and anions, that are also charged. So anytime we can pass electrons or ions in cations and anions form, that will be called passing electricity. If you have a moving charge, moving electrons, that's electricity. You have moving cations, moving anions, that is also electricity. All right. Now, the idea being that we have seen movement of electrons somewhere. This part was seen in metals. This is where metallic bonding or structures come into play. I spent a good amount of time doing that. And remember, metals had a lattice of cations and they had delocalized electrons. Now, those delocalized electrons are moving from one end to the next, which is why you have current. That's what electricity is. Then the idea is that we are going to focus now in this chapter not about passing electrons, but how do these conduct current and times. How can I because these guys are also charged particles. And what we are going to work towards is knowing that in chemistry, you got compounds in two forms. You got ionic and covalent, if you remember. And it's the ionic that have ions, and ions are the charged particles. So the point is that this is the guy we're going to worry about in this chapter, electricity and chemistry. Okay, because what we have realized is that if we pass electricity, or if we pass current or charge, electrons, in covalent molecules or water, nothing happens really. But if I pass electrons through ionic compounds, a sort of decomposition takes place, a chemical change takes place, and that's the part that we're going to focus on, and that's called electrolysis. So this is just a recap on what happens, what I mean by electricity. What we're going to focus on is the fact that we know when we pass current through a certain kind of compound, ionic compound, we actually tend to get a decomposition, a chemical change taking place, and we call that electrolysis. So electrolysis. Okay, now what is electrolysis? It is the chemical reaction. It's a chemical change meaning a reaction, right? Also known as decomposition of sorts. Okay, it tends to be a redox reaction. Okay, redox change when current in the form of electrons is passed through what we call either actually when current is passed. Now through, we'll talk about that, but current passed, or you could say electricity. So that's the crux of the chapter right now. That's what I want to begin with. So yeah, that's a little summary of what we're doing. Yeah, so you all missed classes also. I hope you don't cancel. I missed you guys too. Yes, I did. Sorry, I just saw some of the messages. Some of you, thank you for your kind words on YouTube. I love you all too, and we're going to focus on more of this. So now, where was I now? Okay, so some terms. Okay, now while we have electrolysis, there's a term called electrolyte. Now some terms I want you to learn. So an electrolyte is a liquid or a solution that undergoes electrolysis. So that undergoes electrolysis. Now the reason why I want to focus on the philosophy of this chapter, the theory behind this, is because when I get kids in second year chemistry, they really don't understand why we're doing electrolysis. It's a really big chapter in second year chemistry. So some terms we're going to talk about. So electrolysis is the process by which chemicals break down. Now the chemicals that break down are called electrolytes because they are either solutions or liquids. Generally speaking, it's only aqueous or movable ions, because for you to cause chemical change, first of all, they have to be ions and they have to be mobile. And you realize that ions are only mobile in either in the aqueous form or in the liquid form. So otherwise, a solid ionic compound has no moving charges. A solid metal has moving electrons. Electrons will pass current but will not break down. Ionic compounds in the aqueous or liquid state, if you pass current, you will cause a chemical change. We'll talk about that change right now. It's a redox change, and that's called electrolysis. And the liquid that we're conducting this on is called an electrolyte. And obviously we'll talk about some other terms that come into play right now. Sorry, I'll keep checking your questions every 2-3 minutes. So mobile means being able to move around. Yeah. Okay. Now, so some samples of electrolytes could be, for example, some sample electrolytes are things like NaCl aqueous, or even NaCl liquid, or copper sulfate, let's say aqueous. Because all of these have, when you are an aqueous compound, remember your cation and anion are already separate. Any aqueous compound has cation and anion separate, and same with the liquids. Okay, you have cation and anion separate when you are aqueous or liquid. Okay, and these are, so basically that's why these guys can be electrolytes, because first of all, to be able to conduct current, because you see there are two things that an electrolyte has to happen. It has to be able to conduct current, and then therefore have the chemical change take place. But even before we talk about the chemical change, they have to be able to conduct current. So they have to be ionic compounds that conduct current. Ions, because you need charges, so they have to be ionic compounds that conduct current. Now, what form of ionic compounds conduct current? When the ions can move around. And when can they move around? When they are either aqueous or liquid. Solutions or liquid. Solution means aqueous. So aqueous or liquid is the only two forms that something can be an electrolyte. All right. And what we do is we try to pass current through this. So these solutions are electrolyte, and now I'm going to set up a cell. So basically, we're going to set up a whole system of how to conduct current, how to pass current through an electrolyte. Let me show a cell to you. Yeah. Well, okay, okay, your son, lol. Good luck. Okay, awesome. They're cancelled. Okay, which means few viewers for my videos is fine. All right, no worries. I shall survive. I shall survive. Yay, yay. Okay. Now, sorry. Okay. Okay, Saad, that's pretty funny. Cryolite is not the same as electrolyte. You heard of the term electrolytes in, you probably have heard of the term electrolyte used for your body also. Hey, load up on electrolytes, drink this, drink that, electrolytes. And the reason I call them electrolytes are because things like Gatorade, and the reason why they're electrolytes are because they have aqueous ions. And aqueous ions then help you conduct impulses, electric charges in your body. Your body is capable of passing current. And it's the electrolytes you drink through ORS. When you have motions or stuff, they ask you to drink Pedialyte, ORS, Gatorade. Fill your body with electrolytes. Why? Because they get flushed out when you have bad tummies, and you want them back, otherwise your muscles will cramp. They won't be able to pass impulses to move them around, so they get stuck in a position. You want these ions, because it's these mobile ions. In fact, very specifically, you have a lot of sodium and potassium ions in your body. For anybody studying it later, these guys in your cells help conduct charges, like conduct information. Okay. You like Gatorade? Yeah, like Gatorade. Some of you are writing my messages separately. Yes. Arisha, we'll be doing a lot of organic in questions. Don't worry. Okay. You have me now for the end of the exam, so we'll do some in questions also. Okay. It's so easy organic, by the way, so I didn't realize that, there's some things I didn't have time for. I wish I did. I just was so caught up. Anyways, so away. Yes, I'll be taking most of the classes now. Yes, honey. Yes. 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 Moving on. So here is what we call a cell. So this will introduce you to some of the terms right now. This is what I call an electrolytic electrolytic cell. And what's an electrolytic cell? Basically, we call it a cell because we have power and we're going to pass current through this. It's called an electrolytic cell because we're going to carry out electrolysis in it. And generally speaking, you put an electrolyte in a beaker. So either it's aqueous or liquid. If it's liquid, it's molten, right? So we got your liquid in here. Now you'll notice that this is generally speaking, we pass DC current through the solution. And how you do that is through putting wires inside, literally putting wires from the positive and the negative terminal of our battery inside the solution. We literally treat the solution like a conductor, connect both ends to the liquid. So what we want to do is we want to pass the current through the liquid. So the current goes from the positive to the negative, or the electrons go from the negative to the positive. So you want to do that. That's philosophically what we want to do. Okay. Now to do that, we don't dip the wire directly in. We end up using the help of metals or conductors called electrodes. So these strips on either side are electrodes. They are generally made up of an unreactive metal, either of platinum or graphite. Platinum or graphite, because they are the best conductors of electricity without decomposing. So we want that. We want either, in this case in the diagram, is carbon. Now each electrode gets a name, okay, and the name is given because of a certain reason. So we can ignore the name for a second, but you will later realize that the positive electrode is given a title of anode, and the negative electrode is given a title of cathode. And we'll talk about that in a bit, but that's the electrode given. And this is what's really happening. Now you might never see this in any of the books, because what we do is we make something else. We make a circuit diagram that's a little different than this. The same thing is represented by another way. So this is 3-dimensional, they make a 2-dimensional way. And maybe I can show it to you if I can just get some space, like that, and show you that fellow right here. So it's the same guy here, but the same beaker is drawn like this, is 2-dimensional. You have your electrolyte in it, which is the compound that's going to undergo decomposition, okay, and then you got the current through these batteries. You have a bulb just to show current is going through it, and you have these electrodes. Electrodes just mean the electrodes, you'll have to learn, it's a term used for those rods that pass current. They are given a name, anode and cathode. There's an easy way to remember them, by the way. And you have a battery. So you'll have a battery, wires going into a beaker. The beaker will have the electrolyte. And the moment you set something up like this, you're going to cause a chemical change in the electrolyte. All of this is called the electrolytic cell. Because what does a battery want to do? A battery wants to pass current this way. And what we know is that if current goes this way, the electrons pass the other way. So for us to complete a circuit, this is what we want. We want the electrons to go from the negative to the positive terminal. That's what it means to pass current, that the electrons go from the negative to the positive terminal, negative to the positive. But now instead of going directly, they're going through the liquid, okay, through the liquid. And you might say, well, if it's going through the liquid, why there's a reaction? Well, the problem is that electrons cannot travel through the liquid. So in fact, they exchange electrons here indirectly. Somehow they give the electrons to the solution, and the solution gives the electrons back on this rod, and they come this way. But in the giving and taking of electrons, which is gaining electrons reduction and giving electrons as oxidation, in that redox process a chemical change takes place. So what's happening here is redox is taking place inside the electrolyte, and to fulfill the electron flow, it's all about fulfilling an electron flow. That's all they want to do. they want to fulfill an electron flow. And I'll show that to you in a little more detail. But this is what we call an electrolytic cell. And all the cells will be drawn the same way. Now, the positive terminal will have a certain property to it. The negative terminal will have a certain property to it. And that's what we're going to look at right now. Yes, I'm getting there. I'm getting there. Who was asking? Yeah, you'll get the names very soon. Okay. I'm ending all the syllabi by the end of the month. Somebody's asking when you go by April 1st week. Yeah, is when I'll be done with the syllabus. All right. So, okay. Now, thank you, Narisha. I try to. Now, what's happening? You see, the problem is that when you, okay, let me show this to you. Okay, 1 second. Yeah, no, sir, yeah, guys, okay. You guys have too many off topics. No, I have not abandoned Noon Academy. I'm just teaching from my platform. I'll go there for past papers. All of this stuff I'm uploading on their website also. All right. Other things, I don't know why people have random questions. I don't understand, you know. Why can't we focus? It's okay. Because there's already a plethora of random questions that come on YouTube that I try to ignore. And then there's this. Okay. Somebody's asking past paper sessions. I'll be doing past papers all of April and mid-May. And maybe in June also. All of May. April and May. Okay? Okay, where was I? So let me talk about this. Let me bring that same diagram back because I like that circuit diagram. And let's focus on that fellow for a second. So let's say I have this circuit diagram. Now, let's say I am conducting the electrolysis of, let's take a simple guy, molten NaCl, right? Molten NaCl is a liquid form, right? So you got sodium plus liquid ions. And by the way, the moment something becomes liquid, remember the definition of liquid is the particles are free to move. So they're moving above, sliding over each other. So the ions are free to move. So this liquid, the electrolyte has, like, let's say I'm going to use blue dots, you know, to represent the chloride ions, okay, and yellow dots to represent sodium ions. Just so if you can focus, there are 3 yellow dots and 3 blue dots. The yellow dots are sodium and the blue dots are chlorine. Do you see that? Now, the moment I connect the battery, what you realize is that this electrode, because this is connected to the positive terminal, some physics will come in handy here. This is your positive terminal and the one on the right is your negative terminal. Do you guys see that? Yeah? Are you guys following up? Can I just check? Yeah? Online? So, okay. Now, I don't know where that went. 1 second. Okay. If somebody's asking in the Q&A, I can't see. I can't find my Zoom. My Zoom, whatever that bar is, I can't find it. So it's like lost somewhere. Okay. Okay. Anyway, sorry. So continuing with this. Now, what happens is this. So, once you connect this, what happens the moment you connect is that because they are positive, the rod is positive, it tends to attract negative particles. So, and the blue guys are negative, you see that? And this rod on the right is negative, so it will tend to attract positive particles. So what happens is this, that all the blue which are negative approach the plus charge, and all the positive which are yellow approach the negative plate. Do you follow that? Do you see what's happening here? Because then I'm going to use that to explain to you what's going to happen. So what happens right here, this is that all the positive particles move towards the negative plate and the negative move towards the positive plate. And that's why, let me show you a picture of what's happening here. This is true for all. It doesn't just work for sodium chloride, it is true for all anions and all electrolytes. Okay, what happens is that I'm going to make some space and show you that. So this is what's happening in this. So the positive yellows move towards the negative plate and negative move towards the positive plate. It happens for all electrolysis. Now, but the fun part is, why are they okay? So they moved, but how does this do anything? They just moved. But you understand that for them to have a circuit, they have to have electrons go from here, because you see what is electrons happening here. So when you look at this cell, you need to remember this about science, that electrons travel from the negative terminal and go back up to the positive terminal. And in chemistry, we only deal with electron traveling, for example. So electrons have to go here and they have to go back up. But what happens here is redox reactions take place. That's where the electrolysis is happening. And now pay attention closely here. What happens at the negative electrode, as these positive guys come here, and if you focus here, the electrons are coming this way. So that means the electrons are on the negative terminal, which is this fellow, the negative electrode. So what happens is that this negative terminal has electrons on it. So yeah, these are negative electrons, and those are gained by the positive guy. And the reason why is because there's a buildup of electrons here. If your electrons are building up, they want to move them to the other side, so they have to reduce these electrons. So these positive guys, so what happens is positive ions gain electrons as a reaction taking place right here. Simultaneously, on this side, because you see electrons have to go back from the positive all the way here, so this guy needs to give out electrons. So whatever rod is connected needs to take electrons away from this, but it has no electrons. So what happens is these negative guys, these negative electrodes become neutral and give electrons. For example, sodium positive will gain an electron to become sodium, because remember this was sodium and chloride, and the chloride ions on this rod, all they do is they have an electron, they'll give away the electron, and the electron they give away will go on this rod and then move out and go back up. And that's the only way to complete the circuit. If the circuit has to move, there has to be continuously electrons coming here, continuously sodium gaining them to remove them from here, but continuously chloride giving out electrons here and the electrons going back up. Now since the sodium metal is positive, it's a cation, the rod it's attracted to, it's called a cathode. And since anions, these guys are negative anions, they're anions, then the rod they're attracted to is called the anode. So anode is the rod they're attracted to, and cathode is the rod the cation is attracted to. And basically these are redox reactions taking place, because if you remember, gain of electrons is reduction, while chloride here is losing electrons. What is loss of electrons? Oxidation. So there is reduction in one place, oxidation in the other place, then the electrons transfer and go all through the circuit. That's the crux of the matter. That's what's really happening in a cell. Now you don't have to define all of this in the exam. For the exam is much more simpler, but you have to just be able to understand this is what's happening. I'll summarize it for you in a small table right now. Any questions you have before I summarize it? Yeah, guys. All right. Done? Okay. ठीक है. So if I go back here, so what's happening in electrolysis? All right. So you got the positive electrode and you got the negative electrode, right? And the positive electrode is called the positive electrode is called the anode, and the negative electrode is the cathode. At the positive electrode, the anode, negative ions come. At the negative electrode, the positive ions come. Opposites attract. Okay, so what they do is, so negative ions lose electrons here, and here positive ions gain electrons. Because electrons are lost, this is oxidation, and because electrons are gained, this is reduction, and overall it is a redox reaction. So electrolysis is really a redox reaction, but you are going to use current to force the electrolysis. So now terms, maybe they might become easier now. You have a cell, and the negative attracts positive ions, and positive ions are called cations. So its electrode is called cathode. The negative ions are attracted towards the positive plate. The negative ions are called anions, so its electrode is called anode. Negative ions already are negative, so they're going to give electrons. Positive ions are the ones that are going to accept electrons. So positive ions undergo reduction, negative ions undergo oxidation, and the overall reaction is redox. Yeah? You follow this? Yep. Okay, all good. ठीक है. So now let me give you another example. So let's do an electrolysis on molten zinc chloride. Now zinc chloride is ZnCl2. So that's a liquid. So when zinc chloride is a liquid, it is going to separate into individual ions. You'll have zinc 2 plus liquid ions, and for every one zinc ion you'll have 2 chloride liquid ions. And what I want to do is I want to carry out electrolysis of that. So I have an electrolysis diagram. Can I show it to you? Yes. So I'm going to scroll down, and this is that diagram. Okay, this is a diagram for the electrolysis of, what do you call this? This is molten zinc chloride liquid. So the ions are zinc 2 plus ions and chloride ions. So when you put a battery here, and you notice the plus charge and the minus charge, so this electrode is your positive electrode, on the left, and the guy on the right is your negative electrode, and the electrons go from the negative back to the positive. So the negative electrode is called what? Generally is made up of graphite or platinum, and it's negative because it's negative, so it's going to attract the positive ions. The positive ions are zinc, so you see zinc come close enough, and so that is called the cathode. And at the cathode a reaction takes place. The zinc ions from the solution gain electrons to become the element, and at the positive electrode, the negative ions come to it, and that's why the negative ions are anions, so it's called the anode. So at the anode, the negative ions come into play and give up the electron to become the element. In this case, you'd want 2 chlorines because in the end becomes Cl2. or you don't have two chlorides, you have one chloride, but you become half Cl2, because chlorine, and in the real world you would actually see bubble gas of chlorine gas being released here. And so there are, and these are, by the way, called half equations. These are half equations. A half equation is what? When there's a transfer of electron, very visible. And the cathode pay, there is reduction. Remember that. The cation undergoes reduction and the anion loses electrons and undergoes oxidation. And these reactions taking place is what we call electrolysis. Alright? And at every electrode there is a reaction. Yeah? And there's a very easy way to figure out what's going on. We'll show you very, very easily. But you should know what half equations are. Sometimes you have to balance them, and that's okay. I hope you know how to balance half equations. You could also write this half equation as 2Cl minus becoming Cl2 plus 2E. You can also write this as 2Cl minus 2 electrons becoming Cl2. So losing electrons can be adding on the other side or minusing from the same side, whichever version you want to draw it as. And I'll show you a couple of more examples. Alright? Yeah. How's it going, guys? Azan ho rahi hai, so can you take a 30-second break, please? Rania, that question will be answered in second years. There's a math behind it. Use current and charge to find the quantity of electrons, but we don't do that in O levels. They won't tell you the amount of electrons charged, but that'll be fun. Wouldn't it be fun science? Yeah. Oh, in this case, Miral, we are providing heat because this molten compound needs to stay molten. It's ionic compounds require lots of energy to melt. So if you don't keep it molten, it'll cool down and solidify again. And in the real world, the reaction will stop. But you won't have to worry about that in the actual exam. You won't be heating it. But yeah, that's why we heat it, to keep the ionic compound molten. Thank you, Daniel. I know I'm the best out there, baby. I'm the best. I'm the best. I'm the best, baby. I'm the best. I told everybody this year I'm going to be the best teacher for chemistry in the world. Yep, that's what I'm doing. Anyways, Azan's over. Let's go back. Take care. Now, so the easiest way to figure out what's going to go on in an electrolytic cell using electrolysis, because this is what this is. This is called an electrolytic cell. Let me use that word. Electrolytic cell. Electrolysis. Now, the easiest way to figure out is this. Is that you're going to have an ionic compound. It splits up into positive and negative ions. Aqueous. The positive ions move to the negative electrode because the positive ions are called cations. They move to the cathode, and they move to the cathode to become atoms by gaining electrons. Negative ions are called anions. They move to the anode. Because they're negative, they will lose electrons. Losing electrons is oxidation, and metals gain electron, that is reduction. And this is called redox reactions. And that's literally what you do. Your head has to think that. It doesn't even have to, worry about anything else. Just that. For example, let's say our example was lithium bromide. Okay. lithium bromide liquid. And I want to know what's going to happen. So, well, lithium bromide breaks up into lithium ions and bromide ions. Now, lithium ions are the positive, so the electrode they move to is the negative electrode. Okay, and this moves to the positive electrode. What's the name of the negative electrode? Because it's a cation, the negative electrode is called a cathode. Because bromide is an anion, the negative electrode is known as an anode. The positive electrode pe the cation gains as many electrons to become an atom. So if there's 1 plus, it will gain 1 electron. If it was 2 plus, it would have gained 2 electrons. And in the negative electrode, the anion loses an electron to become the diatomic molecule. So now it's Br2. So now either I balance it by calling this half, or 2 bromide losing 2 electrons to become Br2, or 2 bromides becoming Br2 plus 2e. Any of the three are equally correct. And this is your reduction, and on the right is your oxidation. And that's what you have to know what's going to happen. All right? Does it make sense? Yes, 69 days में A level हो जाता है. Okay, Sherry, thank you. मुझे ना कैलेंडर देखना नहीं आता और मेरी गिनती तो बिल्कुल ही भूल चुका हूँ. Thank you for providing me with the numbers to know कि एग्ज़ाम कब आ रहे हैं. I had no idea. I was not in the business of teaching A levels. The first time I'm doing it, probably. And if anybody didn't figure out, that was sarcasm. Let's move on. Okay. Somebody is telling me, counting the days for me, like, hey, I don't know, exam में time कितना रहता है. Anyways, moving on. Yeah. Anybody have a question about this, by the way, so far? So, you're expected to do this for multiple things. So, like, for example, if I have Al2O3 molten, if I have molten Al2O3, what do I have? I have, when I break this up, I get Al3 plus ions and O2 minus ions. Al3 plus ions are my cation, and O2 minus ion is my anion. So the cation moves to the cathode. Why? Because it's positive and it goes to the negative electrode. And anion is negative, so it will move to the anode, which is the positive plate. And what will happen here? So the aluminum 3 plus is going to gain 3 electrons to become element and undergo reduction. And the oxide ion, it's molten, is going to go to the anode and is going to lose 2 electrons to become the oxygen element. But oxygen is found as O2. So this will have to be O2 minus 2e, becoming half O2 to balance it. Or, like I said, you could put 2O2 minus, double it, double the electrons, and it becomes O2. Either version is fine. And this one is oxidation. And that's the extent of what they're going to ask you. The equations at the anode and cathode, okay, what moves where. That's literally what it is. And once you've mastered that, then they can even ask you, okay, what you produce, what does it look like? Well, for example, aluminum, they'll start asking you that. Well, this fellow is a silvery gray metal, while oxygen is a colorless gas. So in the real world, you will see bubbles of this gas forming at the positive terminal, and at the negative terminal, you will see silver gray metal start to deposit over time. And that's what's going to happen with molten compounds. So these are some examples of that. All right? Sorted? Yeah. Okay, so I'm going to give you, actually, yeah. So I'm going to spend 5 minutes giving you something to do. So I'm going to give you 3 molten compounds. Write their cathode and anode equations. All right. So let's say, let's call it skill check. I'm giving you a skill check. Okay. 1, 2, and 3. One is molten potassium iodide. The second one is molten, okay, copper chloride, and the third one is molten calcium oxide. Write their anode and cathode. So maybe make a table. So write the equation at the cathode, which is the positive terminal, and equation at the anode, which is the negative terminal for all of these 3 compounds. Yeah, do that right now. I'll wait for you guys. Yeah. All right. Awesome. So the cathode equation for the first one is potassium plus electron becoming potassium metal. For the second one is copper 2 plus will gain 2 electrons to become copper. And the third one is calcium 2 plus 2 electrons to become calcium. Then the anode में iodide loses 1 electron to become half I2. Or 2Cl minus will lose 2 electrons to become Cl2. Or 2 minus will lose 4 electrons to become O2. Whichever balancing do you like. You can even write this as 2O2 becoming O2 plus 4 electrons. However you write the equations. Yeah? No, Mason. How many times? Like, I think, no, dude. I'm not going to. Yes, I'm done actually. Shraha. Panic? Why is there panic? Yeah, sorry. My bad. I wrote the wrong charges for the cathode and the anode. The cathode is the negative terminal and the anode is the positive terminal. And all of these 3 reactions are reduction, and all of these 3 reactions on the right are oxidation. Yeah? And anybody has a problem can go back and watch this video all over again, Mason, please. This was so easy. Huh? What happened? Anyways, so, okay. All right, guys. So I'm done with the class today. I wanted to talk to you guys for a few minutes more. We'll do the aqueous part next class. That's when, on Thursday? Yeah. Okay, I'm going to definitely see you guys on Thursday. What was I saying? Yeah. So I plan to finish the syllabus by the 2nd of August, April or something, or 1st of April, okay? And then what's going to happen after that is that there will be 3 classes a week for the IGCSE students and 3 classes a week for the O-level students. 2 of those for each of them I will take, 1 of those Abul will take, each of them. What we'll be doing is I'll be doing twice a week IGCSE past papers and twice a week O-levels past papers, okay? And you can attend all 4 classes because the chemistry is almost the same anyway. So, but they'll be doing separately, okay? Okay. All right. Thank you, Chemistry with the Penguin. I receive your love, and I'm glad you are also doing this. This is good stuff. Okay. Yeah. Anyways. Now, are there any questions somebody has? Yeah? Anybody? Okay. The iodide equation is very simply this, na? You see, it's like if it's Ki, you know it's K plus and I minus. So the cation gains electrons. The anion has to lose electrons. So it's got to lose some amount of electrons to become I2. That's the form of iodine. Now I minus means it has one extra electron. It just loses that one electron. So if it loses that, and now there's one I here, but there's I2 here. So either I make this twice or I make this half. It's easier to make this half because each one iodide loses one electron. Now, for example, if sulfide was to lose electrons to become sulfur, since it's 2 minus, it will actually lose 2 electrons. Now you can write it on the left hand side, or you can write them like this on the right hand side. The trick is that the electrons are negative. So negative on equal side, if this is 2 minus and this is 2 minus, they become equal. Or 2 minus minus 2 minus, which nets out to 0. So remember, the anion will lose as many electrons as they are the charges. So for example, molten oxide, like, right, oxide is 2 minus, so each O loses 2 electrons. But since O exists as O2, I want half O2. And then to remove the half, just multiply the whole thing by 2 if you want to. All right. Okay. All right. So I'm gonna get out now. ठीक है? I know. ठीक है? I'll see you guys next class. Yeah. Yes, thank you, BW Play. Yeah, I'm a big fan of me too. I love watching my own videos too. And obviously my videos will be better than your chem recordings from class. I mean, who better to teach you chemistry than me? I mean, yes, my ego is pretty big, but yeah. Take care, guys. All right, everybody. Khuda Hafiz. I'll see you guys Thursday. Everybody, Khuda Hafiz. See ya when I see ya.